Hi everyone. So today I was reading a research paper by Google. This is related to their embedding model which they have launched recently. So I will just try to see and understand what is an embedding model and how they have pre-trained it and what are the different applications. And we will take help of AI tools, especially Grok, for things we do not understand. So starting with what is an embedding model. So what does an embedding model does is that it transforms input into a dense vector representations. So if you can see here, I will just highlight this. Yes. So which transforms input into dense vector representations. They are pivotal for capturing semantic information across various domains and modalities. Text embedding models represent words and sentences as vectors. Vector in the sense that they provide a uh, number or probability number that how closely two words are related in a sentence, positioning semantically similar text in close proximity within their embedding space. Okay, so this is an embedding model. And the language model is they provide input to output. So embedding model is a part of language model but not the end of the language model. So before if you see a backend process of language model, so embedding is a backend process of a language model, because the language model training they transform that text into a vector, what that embedding does. So what they have done is that they have exposed this embedding model to our use case. Now, what could be the use case? Use case could be that these are the use cases for downstream tasks like information retrieval, clustering, classification. These are the different tasks which can be, yeah, these are the tasks that can be done with the help of these models, embedding model. Now, to train that embedding model, the integration of LLMs have revolutionized the development of high quality embedding models through two primary approaches. Now, what are the two primary approaches? First is that LLMs have been employed to refining the training data set. Okay, we will explain this with the graph, but first let me just highlight this. Yes, LLMs have been deployed to employed to refine the training data set by generating high quality example. And second that recognizing the embedding model parameters are frequently initialized from language models. Researchers have explored leveraging LLM's parameter directly from for initialization. So let us understand this on the growth. So let me share screens of the growth. Yes. So yes. So I have given this example about D2 that we just saw. So what does that mean that improving training data with LLMs? So it means that LLMs are used to create better quality examples for training embedding models. Now this is given a practical example. Now what is practical example? Imagine you are teaching a robot to recognize fruits. An LLM could generate lots of examples like red apple versus green apple that look similar to help the robot learn the difference. This makes the robot a fruit recognition model smarter without needing a huge brain. So to train a small model, we take help of LLM with providing an example. So this is the first, I think, task, and second is the using LLM parameters directly. Instead of starting from scratch, embedding models can use pre-trained settings. They take the parameters of the LLM to start their learning. Now, what is the practical understanding of this? Think of it like using a master chef's recipe which is LLM parameters. To bake a quick cake, that is an embedding model. You do not start from zero, you tweak the recipe slightly and the cake turns out fast. So these are the two methods in which LLMs are helping the embedding model. Okay, yes, yes, that this we have explained I previously that it takes a sequence of words, which is or tokens, into a single compact number pattern embedding that represent all the information in the sequence. Now, how it does that is that transform that with a transformer. A sequence of word like sentence is fed into a special AI model called a transformer and it's sliced from something called Gemini. The this model creates a set of patterns, number patterns, one for each word based on the whole sentence. And then there is a pooling. Then what does that pooling represent? Since we want one single number pattern for the whole sentence, a pooler averages all the word number patterns. Here they use mean pooling, which just means taking the average, scaling the projection. Okay, let us go back to our paper. Okay, yes. Moving on, this is the benchmark reports that this embedding model has been uh, performance report. Now, this benchmark, a special benchmark is this. This is the benchmark that report they have produced, evaluated on the massive multilingual text embedding benchmark, which includes over 100 tasks over across 250 plus languages. It comes out as a number one, including English and coding benchmarks. So multilingual task, bytext mining classification, clustering, multi-level classification. This is the Gemini embedding, this is the Gecko embedding, and these are other models. In this work, we introduced Gemini embedding, a novel embedding model initialized from the powerful Gemini large language model. Leveraging Gemini's diverse capabilities, we train Gemini embedding on a comprehensive suite of embedding tasks. Okay, let me highlight this. To construct a high quality heterogeneous data set. Okay, let me first highlight this. To construct a high quality heterogeneous training data set, we employ Gemini for several critical data curation steps. First step is the filtering low quality examples, determining relevant positive and negative passage for retrieval. Third, generating rich synthetic data set. Synthetic data set is the false data set. This curated data set facilitates training with contrasting learning objective, enabling Gemini embedding to learn robust semantic representation, building upon the success of Gecko. I do not know Gecko. I think this is another embedding model. I do not know it is from Google or some from other company. We will see it later. We incorporate task prompts and a pre fine tuning stages to enhance performance. Finally, utilize model soup, a simple yet effective parameter averaging technique to combine multiple fine-tuned checkpoints, yielding a superior final embedding model. Okay, we need to check out what is model soup. I have not read that paper. So this Gemini embedding achieves a first place ranking on the public leaderboard based on the Borda rank. This is a related work. What is the related work? Text embedding model. Text embedding are fundamental for a wide array of downstream natural language processing tasks, semantic similarity that we have already seen. LLMs for embedding data generation, synthetic query generation. LLMs as embedding models. Several recent embedding models such as E5 Mistral, SFR Mistral, and have been initialized from the adapted embedding model. These models generally outperform the BERT or T5 based models. So the model architecture, an input sequence T of L tokens is processed by M, a transformer, with a bidirectional attention initialized from Gemini, producing a sequence of token embeddings T embed, where dm is the model dimension. What is the training objective? I think this equations I have fed to Grok, refine tuning, fine tuning models, so data sheet, improving data quality, Gemini, evaluation. This is benchmark overall performance. Again, this is benchmark, leaderboard. This is benchmark, ablation. What is the ablation strategy? To better understand how Gemini embedding achieves great performance across many different tasks and languages, provide a systematic analysis of our training recipe. The Gemini embedding generalized to a multilingual task. In table 6, we saw how Gemini embedding can generalize over different language and tasks. Data filtering, future work, conclusion. Gemini. It is a general purpose, highly capable embedding model that capitalizes on the storage capabilities of Gemini to advance the state of the art in representation learning. Okay, let us see the grok that analysis part. Yes. So the question that I so this is the equation. This describes a understanding relationship between the question and answer by turning them into a number patterns embedding. It uses a special training method called noise contrastive estimation with batch negatives, which helps the model learn to tell apart good matches like a question and its correct answer from bad ones, unrelated pairs. So the how to create an embedding. So this is for creating an embedding QI query parameter, query and answer. Now this is for pooling, not query answer. What it means, this turns a query QI like a question and a positive passage. Sorry, this is P plus like a correct answer into a single number pattern. Again, this query and positive passage are turned into a single number pattern. The transformer M processes the input where tau is the task description like question answering. Practical example, imagine the query, what is the capital number of France? The transformer breaks into word patterns, averaging them to get one number. Okay, and F scales it to fit the model. The positive passage, the capital of France is Paris, gets a similar number pattern. Okay, to match a query with a particular answer, again they are turned into a what you call a number pattern and embedding that for a correct query, this is the correct answer. Now this is the loss function. What is the loss function? It is a measure of error, and that is the core goal of a model to minimize the loss function. This decides which comparison to ignore. If two queries are or positive passages are same, mask is 0, no penalty. Otherwise, it is 1. Consider the comparison. Practical example. If Q1 what is capital, Q2 same, mask 1, 2 is 0. So the model does not compare them. Okay. So this is regarding comparing two different queries and giving them a penalty or no penalty score to calculate the score loss function. Okay, this is a negative passage. What is a negative passage? Okay, let's say query is what is 2 plus 2? What is the positive passage? 2 plus 2 is equal to 4. What is negative passage? The sky blue. Why? Because this does not relate to, there is no relation between this query and this passage. So this is unrelated. So this model turns this into a number patterns. Again, everything is turned into a number pattern because every comparison with the help of transformer happens through this number patterns. Compares them and learns that 2 plus 2 4 is a good match, high similarity, while sky is blue is not, low similarity. Over many example, it gets better at matching questions to answer. So a matching kind of a question. Okay, as I read more, I will see because there are, because if you see the research paper, there's a vast amount of reference or research paper in this. So as I read some of them or go through, we can see this has been, or how to actually utilize this in our applications or any task that we are building. Classification, similarity, clustering, ranking, retrieval. Okay, that's all I think. Okay, another tool that I have been using. So this is a deep Y key by, I think, by a company called Devin, which introduced first AI software engineer. So you can paste any uh, code base or here, and it just creates a AI tool to ask questions about how to use that, uh, understanding about that code base. So I have posted a code base of our Gen base. So this is automating prompting, company which automates your prompt engineering itself. So I'm trying to read and understand this wiki, and let's see. But this is a very good, I think, deep wiki. They have multiple, I think, already explored code base. From the GitHub, you can paste a GitHub link and understand and ask questions for that code base. Okay, that's all. And maybe in the next video, I'll try to attend some product question or anything that I have been working on. Okay, thank you.